Silas.
Hi.
How are you?
I'm pretty good.
Good. Did we figure out how to get past Chapter 6 on Miss Sims' page?
No,
Miss Kitts?
I haven't.
Okay. Can you verbalize tonight's problems?
Yeah. I mean, it's all about parabolas.
Okay. Now, are you still learning new material? You're going to hit a point here soon, I would think, where you're done with new material for the semester and then just doing review?
Hopefully. I mean, today was all new material.
Was it? Okay. Most everybody else seems to be coming to that day pretty quick, so maybe your school is different, but I would imagine everybody's getting out for Christmas on the same day, right?
I'm not sure.
Okay. Okay, parabolas. Now, is this parabolas in a quadratic sense or parabolas in a conic section sense?
I couldn't tell you the difference.
Well, there's actually a pretty big difference. I mean, there's not really a difference. The difference is this. Tell me if you've seen this. You seen that formula for a parabola?
No.
Okay. So we're not dealing with the conic section. In other words, we're not going to be dealing with foci, directrix, or any of that?
That doesn't sound familiar.
All right. So you're not into conic sections. So what kind of parabolas are we going to be dealing with? What do we need to do with them?
First problem I have is write an equation with the vertex at the origin and the given focus.
Okay. Ah, we are in conic sections. Okay. Focus is what?
6, 0.
Okay. Let's talk about parabolas for a moment. If we take your basic y equal x squared, parabolas actually have a very interesting mathematical definition. And that definition is there is a focus somewhere inside that parabola. Hold on. Wow. Hold on. Oh, that was my x-axis. Oh, that was my y-axis. There is a point somewhere inside that parabola such that every point on the parabola is equidistant from that point and the directrix. In other words, that line is equal to the length of that line. I didn't draw my directrix quite right here, but we're close. If I put a point up here, that distance is the same as that distance. So that becomes kind of the new definition for a parabola. All right, you with me?
Yeah.
So we have two new things to worry about. We have something called a focus and we have a directrix. The directrix is a horizontal line, assuming we have a vertical vertical parabola. Because we do have other options, we can now talk about parabolas that are sideways, like that, when we're dealing with conic sections. They're not functions, because they don't pass the vertical line test, but they're still parabolas. So let's talk about a vertical parabola. We come up with a new standard format for it, which actually not positive your school necessarily uses, because schools Some don't use this. There's your standard formula. P is this distance from the focus to the vertex, and it's also the same distance to the directrix from the vertex in the opposite direction. Okay? So if I gave you the following, and H and K are the vertex. So if I give you this equation, tell me where's the graph start? What is its focus, and what is its vertex, and what is its directrix?
I have no idea.
Okay. Well, first of all, let's look for the vertex. It was x minus h, so h is 2, and k is minus 3. So the vertex, which is always the most important thing in a parabola, is right there. Let's label that as 2 minus 3. Now usually when they're talking about parabolas and focuses, they're not interested in the x-intercept so much. They're going to say, where is the focus, which is somewhere in there, and where is the directrix? If x minus h squared is equal to 4p times y minus k, what is p? Solve for p. In other words, this 4p has to equal this 8. So what does p equal to?
2.
Yeah. And what that means is that the focus is 2 units above the vertex. So the coordinates on the focus would be 2, minus 1. And the directrix is always perpendicular to the line that connects the focus and the vertex, and it's the same distance from the vertex that the focus was. So what is the equation of this horizontal dotted line? Two units below minus 3.
So 2 minus 5.
Y equals minus 5. In other words, the directrix is a line. It's not a point. So to define the directrix, we need the equation of a line. It's not a point with an x and y coordinate. Okay? So that's how we use this 4p, is that we try to get the equation in this format, and then whatever this coefficient is, we set it equal to 4p. We solve for p. Now we know where the focus is, and we know where the directrix is. Okay, so let's see. The problem you had said that the vertex is at 0, 0, and that the focus was at 6, 0. So if I want to write that, h is 0, so I've got x squared equals, well, I know p is 6, right? So 4 times 6 times y minus 0, or just y. So my equation is x squared equals 24y. That's the answer to that problem. Hold on. You said the focus was at 6, 0?
Yeah.
Well, let's go back a moment. There's two different formats. This format here is for vertical parabolas like this or like this. The x term is squared, the y term is not. That's how you get vertical parabolas. If you give the format like this, which you haven't seen before because this isn't a function, but it's still very applicable in parabolas. Notice the difference between these two? In the second one, it's y squared equals x to the 1 power. These parabolas look like this, or like that. Not both at the same time, but it's just like a vertical parabola. If that coefficient is plus, it opens up. If the coefficient is negative, it opens down. Well, with a sideways parabola, I call these horizontal parabolas, it opens to the right if that coefficient is positive. It opens to the left if the coefficient is negative. Now, they gave us a focus of 6, 0. So they have to be talking about a horizontal parabola because that focus is right there, 6, 0. They couldn't be talking, not if the vertex was at 0, 0 of a vertical one. When I first saw it, when you first gave me the problem, I just assumed the first problem would be a vertical parabola. So I drew it as a vertical one and put that point in there and realized, well, that point's 0, 6. So if the focus is at 6, 0, it's on the x-axis, therefore it has to be a sideways parabola. So the same essential solution, I know that p is 6, but it's y squared equals 24x. That fits those 2 points. So when you're dealing with parabolas, the first thing you have to kind of determine is whether you're dealing with a vertical or a horizontal one. Because vertical ones use this format, horizontal ones use that format. All right, you got another one? I'm going to leave those 2 formats up there for the moment.
Yeah, the other one would be it's identify the vertex, the focus, and the directrix of each graph, then sketch that graph. And it's y equals -1/4 x squared.
Okay. Based, which is this? Is this a vertical or a horizontal parabola? The way to remember it is the quadratic that you've worked with for years looks like this. That's y equal x squared. So this has to be a vertical parabola. Okay? So we are going to attach it to that format right there. What is the vertex?
Would be 0, and then a 4th.
0, 0. In other words, both h and k are 0. Okay? The focus, well, to find the focus, first of all, we have to figure out what p is. So what is 4p equal to? Now remember, I got to get this in this format right here. Right now, it isn't in that format. So what do I have to do to this equation to get it into this format? In other words, I can't equate 4p to minus 1/4 because the 4p is the coefficient of the y term, not the coefficient of the x squared term. So the first thing I have to do here is multiply both sides of the equation by minus 4. Now I have it in the form that I want it in. In other words, now I have it in this format. So what is p equal to? I got it reversed, but it's in that format. In other words, I got the x squared on the right and the y on the left, whereas this format has the x squared on the left and the y on the right. But I can still calculate p now. I have everything I need to figure out what p is. Equate 4p with this coefficient and then solve for p.
-1.
Yeah, so p is -1 because 4p is equal to -4. Okay, so we know the focus is down 1 from the vertex. And we've already figured out that it's a vertical one. So what is the coordinate on the focus if p is -1? The focus is a point. What's the Well, what's the x coordinate going to be? If we're looking at a parabola that looks like that, a focus is in there, so the x coordinate has to be 0, right?
Yeah.
Excuse me, I drew this wrong. We know it opens down. So the focus is there, not there. You with me? Sorry for the confusion. But the focus is same x-coordinate as the vertex, but the y-coordinate is down by the focal amount, which is -1. So the focus has a coordinate of 0, -1. And then what about the directrix? What's the equation of the directrix?
I don't know.
Well, it's y equals, we know this distance is the same as the focus, so it's got to be y equal 1. In other words, the same distance from the vertex to the focus is the distance from the vertex to the directrix. We don't actually draw this. The reason I make it a dotted line is because when you graph this parabola, you don't graph this directrix. But it's useful to know because parabolas have very interesting reflective properties. This is the way light bulbs or flashlights are made. Is you put the light bulb right there. And every light ray coming off the light bulb hits the side of the parabola and goes straight out, no matter what angle. That's what makes parabolas so beautiful to use for telescopes, flashlights, receiving antennas for direct TV. They're all parabolic shaped. And the receiver is right there where the focus is. So knowing how to find the focus on a parabola has a lot of very practical uses. Okay, you got another one? Yeah, let's just do the next one in line. What's the equation of the next one?
Same thing, but it's y squared minus 25x equals 0.
Okay, it's not quite the same. Is this a horizontal or a vertical parabola?
horizontal.
Yeah, so I'm going to use this as my standard. So let's try to get this into this format, and then I'll be able to figure out what P is. So what do I have to do to this equation to get it into this format that I have squared over here?
Add 25x.
Okay, that's a good start. In fact, that's it. Now what is P going to be? First of all, I guess let's answer where's the vertex. Vertex is H and K. What are H and K in this case? Both 0. In other words, this isn't y minus 1 squared, and this isn't 25 times x plus 2. In other words, K has to be 0 and H has to be 0. So our vertex has to be at 0, 0. Okay, now we can calculate P. How am I going to solve for P? What does 4P equal to?
25x.
Just 25. Just the coefficient.
Okay.
Okay, in other words, equate those two. So 4P equals 25, P equals 6 1/4. So where is my focus? Remember, this is a horizontal. In fact, let's do a semi-graph of it. We know the vertex is there. We know it opens to the right because it's got a positive 25. Excuse me, it opens to the right because it's got a positive number in front of the y squared. So we know that we're looking at something like this, and we know the focus. What's the coordinate on the focus?
The 6 1/4, 0.
Uh-huh. And the directrix is always perpendicular to the line connecting the focus and the vertex. So the directrix is always outside the parabola and the same distance from the focus. So what's the coordinates of the what's the equation of that line?
Negative 6 1/4.
X equal negative 6 1/4. That's it. That's exactly what you want to do on all these. Figure out whether it's vertical or horizontal. Use one of these two equations based on which it is, and then go through that exact process every time. Okay, so we got 5 or 6 minutes. Let's do another one.
X squared equals negative 4y.
Let's do a harder one. All of these have a vertex at 0, 0. Find the first one that doesn't have a 0, 0 vertex, since we only got 5 minutes more.
They all do.
Can't go down a section? Really? You don't have any. You don't have any where the vertex is not at 0, 0?
Nope.
Okay. All right. And that's all you have to do tonight is these?
Yeah.
Okay. Let's do another one of those. And what was that last one?
X squared minus 4y.
Equals 0?
It just says x squared. No, it's x squared equals negative 4y.
Vertical or horizontal?
Horizontal.
No. Remember our classic that we've always learned is y equal x squared. We know that's vertical. So if you have the y without any power to it and the x has a square on it, you know it's vertical. In fact, this is not only vertical, but it opens down. In other words, it does something like that. Because the x squared actually has a negative coefficient if we solve for y. In other words, if we let y equal negative 1/4 x squared, then we know it opens down. Okay, so our focus is going to be somewhere in there. I cannot do that. There we go. So where's the vertex?
0, 0.
Okay. What's P? Did we do this one already? Did we do this one? Maybe not. No, we didn't do it, I don't think. So what's P? What's 4P equal to?
Negative 4.
Uh-huh. So what's P?
Negative 1.
So where's the focus? What's the coordinates of that point?
Negative 1, 0.
Look at it again.
0, negative 1.
Yep. And the equation of the directrix is
0, positive 1.
remember, it's the equation of a line. The directrix is not a point, it's a line. Y equals, where is that line?
1.
Y equals 1 is the directrix. Okay? Let's do one more real quick. Give me one more.
Negative 8x equals y squared.
Horizontal or vertical?
Horizontal.
Okay? Where's the vertex? The vertex on all of these is at 0, 0. If we had a y minus 2 squared, then the vertex wouldn't be at 0, 0. It would be at 2 or 0, comma 2. So when you do go to the next step, that's what you'll go to, is where they'll have the vertex that's not at 0, 0. Okay, so I know this is horizontal, so I got to relate it to this one. What's 4p equal to?
Negative 8.
P is equal to negative 2. I know I'm dealing with, is it open to the right or to the left?
To the left.
Yeah, because of that negative sign. So it's like that, which means the focus is going to be somewhere there. The directrix is going to be somewhere there. What's the coordinates on the focus?
Negative 2, 0.
And what's the equation of the directrix?
Y equals negative 2.
X equal positive 2. Remember, it's always on the other side of the vertex. It's always on the other side of the focus. It's never inside the parabola. It's always outside. And when you're dealing with sideways parabolas, it's always an x equal. Vertical lines are always x equal. Horizontal lines are always y equal. All right. I actually think you got it down there, don't you?
Yeah, for the most part.
Okay, good. Tomorrow we'll probably talk about circles and ellipses. My guess is what you got coming up. Conic sections are parabolas, circles, ellipses, and hyperbolas. And all of them have focuses and centers, and so I'm sure that's what we'll be covering tomorrow night. All right?
Okay.
I'll talk to you tomorrow night.
Okay.
Bye-bye, Si.